Assalamu alaikum. My name is Muhammad Ibrahim Khan, and this is my presentation for FPC Assignment 2 with Muhammad Arbab. So, our case study over here was the GeoTrees platform experience, which was done by the researchers of UTM to monitor tree growth and estimate carbon sequestration potential of trees planted by individuals and communities. So the user can register trees, input maintenance activities like watering, fertilizing, calculate potential carbon offset values. So the objectives of this assignment and our project, which we did, was to create a console-based simulation system in C++ that users could use as a menu-driven interface on a console so that you can register tree information, input tree maintenance activities such as if it's water, pruned, etc. Calculate the estimated carbon sequestration by using a formula that we were given, and display the basic report of all trees, so the summary of all the trees that we have made. Okay, and now we can move on to the source code, which is in this Google Drive, but we also have screenshots over here. And just for clarity, I'll use my own IDE editor, which is C Lion. And I'm using my own editor over here first, which is C Line. And this is our whole code base, which which I created, and then Mohammed Abba worked on the documents. And we're using C time, CT type, CMAT, and basic, most commonly used C libraries. We start off with the trees pointer, since I was using dynamically allocated arrays, pointers, and the requirements which it required. And so, just starting off with the program, when we run it, we can see that we have a menu-driven console interface. And so the first thing it will do, it will enter a do-while loop, which has a display main menu function. We have, I think, about 8 functions here, right? Yeah, about 8 functions over here. And the first case that will take is case 1. It will call the function register trees. Now, if in case a user types in an invalid input, it will notify your user, which is an invalid input. Let me just make this a bit bigger. And so we can go ahead and register for a tree. Let's say one tree, T001. And we can make our species. We can also put in our DBH, which is about 15, let's say. And let's say we put in something invalid. So it also has input validation, so we don't have to worry about that. So let's say our height is 4 meters. So now, so far what has happened is it went through register trees. First it called the display menu, right? Then went to a register tree, looking for an input and making sure our input is valid. If not, it will spit out this statement and make sure our keyboard buffer is cleared, obviously. Make sure we deallocate our memory also. And also we're going to then enter our for loop. So whatever we have entered, so let's say we entered 5 trees we want to enter in. So we're going to loop through this for loop in about 5 iterations. And we'll have the same input, say enter details for a tree, and then it'll say the number for that tree. You can see that over here. That when we said enter details for tree 1, and if we say enter trees for, let's say we said 5, so it'll say enter detail for tree 1, 2, 3, and so on. And so we can use a boolean. I'm using a boolean variable over here if there's a duplicate tree, meaning so that would not, it would not allow that. Yeah, it would not allow that, and it would say you have to use a unique tree ID. And that's basically it. We do the same thing for, we have input validation for the other variables such as height, dbh, and so on. And now we can move on to the second choice that we have, which is input tree maintenance activities. So let's enter that and enter your tree ID. So let's say we enter a random value. So it will say tree ID is not found, since good is not one of our tree IDs. So let's go back to our tree ID, which is T001, which we entered here. And so if we click 2 and enter our tree ID to update our maintenance, we can, it even says what our tree maintenance is. So we can say if we watered it, and let's say we put in something that's invalid, it has input validation also again. And let's say we didn't fertilize it, we pruned it, and we didn't weed it. And so now we can calculate by using choice 3. It will show us the carbon sequestration and the CO2 equivalent, and these are not rounded values. And we can press up 4 to create a report. And lastly, we can exit our program and deallocate our memory. We can also check our tree report, which we created, and we have the date and time of the plant, which is using the ctime library. We have our tree summary. Since I only entered 1, it has only 1, and so on. Okay. And now we can go back to our presentation. And this is the whole code base, and we have our sample inputs and output cases also, like normal. And that's about it. Thank you for my presentation. Yeah, that's basically it.